Okay, so today we'll study some concepts on current and electricity. Okay, so the two major things that we'll cover today is one is Kirchoff's rule, and then we'll cover the Whitstone Bridge. Okay, so I'll just write down the important points. Okay, what is Kirchoff's rule? Kirchoff's rule. There are two rules of Kirchoff's.
Junction and
One is junction rule. Junction rule. And the other one is the loop rule. Loop rule. Okay. So what does junction rule says? Okay. So the junction rule says at any junction the sum of current entering is equal to sum of current leaving. So at any junction, that is important. At any junction in an electrical circuit, sum of current I entering is equal to I leaving. I leaving at any junction. Okay. So you imagine a junction, like say this is an electrical circuit. Say this is one resistance, and let us say this is another resistance. Okay. This is another resistance. Okay. So let us say this is a cube. Okay. So this is another arm of the cube. This is another arm of the cube. Okay. So let us say in this cube there is some current entering. Some current, let us say 3I is entering.
okay.
Why you have put 3I? Because it is a cube and it has three sides and all. So let us say it has some potential difference and the current of 3I is flowing. Okay. So if a current of 3I is flowing and the resistance is R here, 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 the resistance is R here. And all the resistance are equal.
Yes.
So 3I is flowing here. So if 3I is flowing, so this is your junction. Actually this is your junction. So as per energy conservation, 3I is coming means 3I will go out. And if the three resistance are equal, it will get divided equally. But if the resistance are different, then it will not get divided equally.
Different resistance.
If your higher resistance means less current. So, but here in this case,
they are all equal.
They are all equal. So 3I will get divided into capital I, and capital I.
Yes.
So this is how it will get branched out. Okay. Then after you finish one junction, you go to another junction. So junction by junction you will go. So here I has entered, that means if again equal resistance it is facing. So I will get divided by I by 2 and I by 2.
Okay,
Clear?
I is entering.
I is entering here. This I is getting branched out.
So I will only come out. So I by 2, I by 2.
So I by 2. So this is what is the junction rule. Okay, then what is the loop rule? The loop rule says algebraic sum of changes in potential around any closed loop. So in any closed loop, change in potential change in potential around any closed loop involving resistors and cell is zero. Involving resistors and cell equal to zero. So change in potential in a closed loop, change in potential in a closed loop involving resistors and cell is equal to zero. That means suppose you just imagine a simple, this is your resistor, this is your cell, okay.
Yes.
So you are saying this is EMF, this is resistance, and let us say current I is flowing here.
Yeah.
So this is a closed loop. Okay. Always the current flows from positive to negative.
Negative.
So your current is flowing like this and current is entering like this. Okay. So your E minus IR is equal to 0. So this is equal to 0. So
Take
change in
direction.
potential, take in this direction. Okay.
Okay.
So change in potential involving resistor. So this is a cell, this is a resistor. So change in potential is equal to
Zero.
0. So this you can apply for any complicated circuit. This is then say you can have multiple resistors and all. This is the simplest one. You can have multiple resistors, but you can go loop by loop. A circuit can be complicated, but you can go loop by loop using this principle. Okay, you can go loop by loop. So these are the two.
Kirchoff law.
These are the two Kirchoff's rule. Okay. So these are the two Kirchoff's rule. Loop by loop we can go, we can have any complicated circuit also. Let us say I will give example of a complicated circuit. One second. You can give example of any complicated circuit. Okay. Any complicated circuit. This is one, and then this is one circuit. Then this is one. Okay. So this is here there are two loops. Similarly, you can have this and this, okay, and then this. Okay. So in this case, let us say current flows like this, then current goes like this, then current from here it is from plus to minus, from this side you will start like this, then it goes like this, okay, then this is like this, okay. So this this to come here means it will go out.
Up.
It will go out like this. Okay. Then this.
That will get split into this and
This
that.
will get. These two are coming in means this has to go out. So let us say some typical example. This is 4 ohm. This is 1 ohm. 1 ohm. Okay. And then this is 2 ohm. 2 ohm. And then this is also 2 ohm. Okay. 2 ohm. And this is 5 volt. And this is 10 volt. 10 volt. Okay. And let us say this, there is a resistance here. This is 4 ohm. 4 ohm. This is 1 ohm. 4 ohm. Okay. So like this, so in this circuit, this is a little bit complicated circuit. Here you will apply both junction rule and loop rule and solve this thing. So here this is one loop, this is another loop, this is another loop.
The whole circuit is also a loop.
The whole circuit is also a loop.
4 loops.
There are 4 loops. So using so in your book one numerical is given that you can solve and show me how you are using. Okay.
In each loop.
So basically you are using 2 laws of Kirchoff's. One is junction rule, another is loop rule. Junction rule says the current entering is equal to the current leaving. Okay. At any junction, delta I entering is equal to delta I leaving. And the loop rule says change in potential involving resistance and cell in a circuit is equal to 0.
In a closed loop.
So these are the 2 basic laws. So this will govern any complicated circuit. It can be simple, it can be complicated. Okay. So these are the 2 major laws of Kirchoff's. Then another concept which is very very important and you can get many numericals related to that is your Whitstone Bridge. Okay. So we'll get into that Whitstone Bridge. Okay. So we are done with Kirchoff's rule. Now we will get into Whitstone Bridge. We are done with Kirchoff's rule. We will get into Whitstone Bridge. These are all name of scientists. Whitstone's Bridge. So how does a Whitstone Bridge looks like? Okay. How does a Whitstone Bridge looks like? So okay. We have a Whitstone Bridge. And you have a galvanometer. Okay. A galvanometer can be a ammeter, it can be a resistor. All concept starts with galvanometer. I'll tell you what is a galvanometer. So it is a galvanometer. The symbol is G. Okay. Okay. So now you have this. Okay.
Yeah.
Now you have some potential difference. Okay. So you have some, you are applying some potential difference. Okay. So this is your bridge and you are applying some potential difference. Okay. So this is your Whitstone bridge. You have a galvanometer. Let us say there are four corners A, B, A, B, then this is C, and then this is D. Okay?
Yes.
So, what is written in R1? No? This is R1.
This is R2. This is R1. R3, R4.
So this is R1,
Yes.
this is R2, and which is R3?
This one.
3 is what? This one.
This one.
Okay. So this is R3, this is
R4.
R4. These are the four resistance. Okay.
Yes.
So, okay. R1, R2, R3. So, Weatstone Bridge. So Kirchoff's rules, you will apply Kirchoff's rule to the Weatstone Bridge and solve it. Okay. The bridge has four resistors R1, R2, R3 across one pair of diagonally opposite points A and C in the figure. Okay. In the figure, a source is connected. So across A
The
and C,
voltage
you are
source.
connecting a source, voltage source is connected. This is called battery arm. Okay. So A to C, AC is called battery arm. Battery arm.
This voltage is connected across that.
This is called battery arm. AC is battery arm. Okay. Then galvanometer. So BD is called, there is a galvanometer you are connecting. So BD is called galvanometer arm. Galvanometer arm.
Okay.
There are two arms of a Whitstone bridge. AC is the battery arm. BD is the galvanometer arm. Okay. For simplicity, we assume that cell has no internal resistance. Here, this does not have any internal resistance. Otherwise, you could have put a resistance here like this, right?
Yeah.
But you assume that
It is not there.
it's not a dry cell and it
No.
does not have any
No.
resistance. Okay. In general, there will be currents flowing across all resistors as well as current Ig through G. So in general, there will be some current flowing Ig through G.
Not Whitstone current.
EAG. Of special interest in case of balanced bridge. So Whitstone bridge is a balanced bridge. In balanced bridge where the resistors are such that Ig is equal to 0. So the current flowing through this galvanometer is equal to 0. That is a special case.
That is
That is Whitstone bridge. Yes. Real 0. We can easily get the balance condition. We can get by adjusting the resistance such that there is no current through the galvanometer. In this case, the Kirchoff junction rule applied to junction D and B, junction D and B, D and B. Okay. So D and B, we apply Kirchoff loop rule AB, ADBA and CBDC. Okay. So there are for Weatstone bridge we will be applying two rules of Kirchoff's. Okay. One is junction rule and another is the loop rule. Okay. So there are two junctions. One junction is D, another junction is B. Okay. So through this current flowing is I2, let us say. Through this current flowing is I4, let us say. Right? Just nomenclature.
I2 minus I.
So at junction B, whatever current is going, and that will go out because in this arm there is no current.
That is the
That is
balance
the rule
condition.
of the
Weatstone
Whitstone
condition.
Bridge. So at junction B, I2 is equal to I4.
I4.
That is one rule. Okay.
Yeah.
Similarly, at junction D, let us say this is I1 and this is I3.
I3.
So I1 is equal to I3. This is another junction. Okay.
Okay.
I1 is equal to I3. Now we have to apply the loop rule. Okay. So there are, what are the loop rule? ADBA is one loop. Okay. So ADBA is one loop. This is one loop. So loop 1. ADBA. Loop 2 is
BCDB.
Loop 2 is CBDC. Loop 2 is CBDC. Okay, so these are your two loops. Okay. So if you consider ABDA, what does it really indicate? Okay. So you are assuming that the current is flowing like this. This is your assumption. Okay. So here current is 0, so the current will go like this. Okay. Then once the current and here also you are imagining as if the current is getting branched into two.
Okay.
So this will go like this. This will go like this. This will go like this.
Yeah.
Okay. So if it is coming like this, here current is 0, it will go out like this. 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 So these current will finally go out like this. So you have got the direction of currents now. Clear?
This the one that goes through R3, it will go like this direction.
Because it is coming like this direction. In this current, in this arm, there is no current.
Okay.
So whatever is coming, it has to go out as per junction.
Yes.
Okay. So you got the direction of current. Okay. So now we apply the rule to the loop ABDA, ADBA, that loop. So it will give you
I2 R2
so
minus I1.
actually you follow a loop like this. Okay.
Yes.
You follow a loop like this.
Yes.
So if you follow like this, whatever is following, the arrow, that is positive.
Yes.
What is like
your assumed direction.
So your assumed direction is this. So here current is flowing in your assumed direction.
Yes.
But for this resistance, the current is flowing opposite to the assumed direction. So here your assumed direction is like this, but the current is flowing the opposite.
Minus sign.
So that's why minus sign will come into picture. So I2 R2 is positive. I2 R2 is positive minus I1 R1 plus this is 0. Galvanometer does not have any resistance. So plus 0 is equal to 0. That is one. So similarly, this is equation 1, let us say. This is for loop ADBA. Similarly for loop CBDC, there is another loop CBDC. So that is CBDC. Okay. So again you apply this loop, this direction. So this R4, it is against, it is flowing as per this, but R3 it is opposite. Okay. So R3
minus R3 RIN.
Okay, so what will happen? This I4 into R4. This is as per direction. minus I3 into
R3.
R3 is equal
Because
to
that is in opposite direction.
I3 into R3 is equal to 0. But you know that I2 is equal to I4 because there is no current here. So I2, the condition is I2 is equal to I4. Similarly, because here there is no current, I1 is equal to I3. I1 is equal to I3. So that is as per galvanometer, because there is no current in the galvanometer, that is there. Okay. So this is one important thing. This is one important condition because here there is no current. So I2 is equal to I4, I1 is equal to I3. So this is one loop rule. This is another. This is loop rule. This is also loop rule.
Taking two
And
loops.
and then this is junction rule, and then this is junction rule.
Junction rule.
So these are using these all these things. You will so this equation will become in place of I4. You will write I2 because I4 is equal to I2. So I2 into R4 is equal to I3. I3 is equal to I1. So I1 into R3 is equal to 0.
0.
Okay. So you have got this equation. So I2 R2 is equal to I1 R1. Similarly, I2 R4 is equal to I3 I1 R3. Okay. So what you got here, I2 minus I1 is equal to R2 by R1. I2 by I1 is equal to R1 by R2. Right?
Yes.
Similarly, I2 by R1, I2 by I1 is equal to R3 by R4. So this is your equation 3, same. This is your equation 4. So these two terms I2 by I1 is same. That means R1 by R2 is equal to R3 by R4. So R1 by R2 is equal to R3 by R4.
Yes.
This is the final governing equation. So what you have to remember, like this is R1, this is R2. This is R3, this is R4. Just remember the lower one are R1, R3. The upper one are 2, 4. Lower one are 1,
Because
3.
when it's not Whitstone Bridge also you have to learn how to apply that law.
Yeah. So you just remember in Whitstone Bridge these are 1, 3, these are 2, 4. Lower one, 1, 3.
Resistances are.
So now you know what it is and what is Whitstone Bridge. That is the principle of Whitstone Bridge.
Yes.
Okay. So there can be a generalized in this case the main governing thing is the resistance of the galvanometer is equal to 0.
Current flowing through the
And current flowing through is through it is also 0.
That wouldn't have been 0, there would have again been one more term.
So you can have a generalized case in which the galvanometer will have some resistance. If the galvanometer has some resistance, some current will start flowing there and it will become a unbalanced bridge.
It won't be
So the Whitstone bridge is a balanced bridge through which through the galvanometer no current flows and R1 by R2 is equal to R3 by R4. So R1 R2, R3 R4. You do remember it like R1 by R2 is equal to R3 by R4. So there is a numerical given where the galvanometer has some resistance of 50 ohm.
Then you have to consider galvanometer also.
Then again you have to use loop rule and junction rule and solve it.
Same like this, but there will be another for galvanometer.
Yes. So that is your homework. Okay. So this much I have explained you today about junction rule, about loop rule of Kirchoff's, and by using loop rule and junction rule, how you arrive at a balanced bridge, which is a Whitstone bridge.
Okay.
These are very, very important concepts, and in every entrance examination at least 1 or 2 numerical will come from this. Okay? So the one with generalized case with some resistance, you solve it and show me.
Okay.
Okay? Okay. Fine.